Okay, so let's get started with section 6.2. This is the indefinite integral. It starts off by talking about how the integral of f of x with respect to x is equal to f of x plus a constant. So this plus a constant is what I was talking about on the neon sheet as to why I need the plus c. So right here we're taking the integral of the function, and you can see it's going to be a new function plus c. Okay. Why do we have to worry about the plus c? Well, let's pretend that I give you just a regular function. We'll do like f of x equals 3x squared plus 5. And if I ask you to take the derivative of this simple function, we would take the derivative and we would all get 6x. The problem is when we take the derivative of our constant 5, that 5 goes away because the derivative of a constant is 0. So if we look at integration as the opposite operation of a derivative, if I start with this function, 6x, and I say let's take the integral of 6x dx. Okay, I have to put the dx there because it's saying, hey, take the integral of this function with respect to x. That's the letter in the problem, so I put the dx. If I take this integral, to find integral, if you read these directions, it says to integrate, what we're going to do is add 1 to the exponent and then divide by that new exponent. So that would give me what? It would give me 6x squared because I'm adding I'm adding 1 to my power. And then I divide by that, and then I always put plus c. When I reduce this, you see that I get 3x squared plus c. And if you look at my original function, there's the 3x squared, and that plus c takes care of the plus 5. If I don't put the plus c, you can see where we'll lose something. And that's why we have to worry about the plus c with integration. Okay? So basically, that's the gist of how to take an integral. It's very easy. You just have to, again, add the power, add 1 to the power, divide, and add a plus c. Okay? So let's move down here to our next example. Okay. Again, just to highlight something for you, in this block, I would highlight think of the integral as the opposite operation of differentiation. This is why on your neon sheet I showed you how to kind of go back and forth between the two different columns. If you know your derivatives, learning the integral should be fairly easy because you're just swapping them like I was talking about. So that's definitely something to note. And also, this word antiderivative is the same thing as the word integral, depending on like what your textbook uses. They are synonyms. Okay, so let's get started taking some integrals. Okay, so number 2, we're going to take the integral of x squared dx. And again, this dx has to be here. It's really important because later we're going to have different letters. And so right now, it's simple. Seems like, no big deal, but they will make a difference soon. Okay, so here we go. We're going to take our x. We're going to add 1 to make that a 3. We're going to divide by 3, and we're going to put a plus c. Of course, you could write 1/3 x cubed plus c, but that would be fine right there. Okay, next, if we have 1 over x to the 5th, most of us have been taking the moment to write this as x to the negative 5 dx. So right here, I'm not taking the integral, I'm just rewriting the integral. And now I will take the integral. I have x. I'm going to add 1, which gets me negative 4. And then I'm going to divide by that negative 4 and add a plus c. Okay? As far as how to leave your answer, that's not wrong, but I would much rather you say this is a negative answer due to this symbol here. The x to the negative 4 needs to go to the denominator as x to the 4th. Knowing a negative exponent drops it, and then I would just do something like this. Okay? And then we have to, of course, put our plus c. Okay? So definitely try to never leave a negative exponent. I would much rather you leave this. And again, you can see the there. Okay? Next, we have our integral. I'm going to write this as x to the 1/2 power dx. Okay, take a second and do that yourself. Okay, I'm going to keep going. Of course, you can always pause the video if you want a little more time. We're going to take our x. we're going to add 1, which is 2 over 2, which gets me 3 over 2. Then I'm going to divide by that 3 over 2, and then I'm going to add c. As usual, I don't want you to leave that, so if you think about that, if you're dividing by, so let me put some work here, dividing by 3 over 2, aren't you really multiplying by 2/3? Okay, so what should this real answer be? It should be 2x to the 3 over 2 over 3 plus c. Okay, and then we're ready to move on. Example 3. Okay, so some vocab and symbols again mapped out for you in your notes. Here you see they're pointing out that this is your integration symbol. This right here is called your integrand, if you're ever looking to say that out loud. Again, dx identifies the independent variable, or the variable we will take the integral of, or with respect to, and again, that's going to become important later. And c is the constant of integration. Okay, this is the table that we just talked about, so I'm going to go through that. That's not in your notes, so I did that separately. Okay, so let's get moving to example number 4. Okay, so this is where you would probably want to pull out your notes, your neon sheet, and if we're going to take the integral of the secant squared, just look and find it on your neon sheet. Think to yourself, what derivative has the answer of secant squared? And when you think, oh, it's tangent, then you know the answer to this question. Okay, remember, it's just the opposite of the derivative. The derivative of tangent is secant squared, so the integral of secant squared is going to be tangent. Just don't forget the plus c. Okay, with part B, we have 3 over 2, which is a constant, so the 3 over 2 can be pulled through. So let's take a moment and rewrite that. Okay, I'm also going to write x to the 1/2 power dx here, just to make everything simple. Okay, and then we're going to go through and take our integral. So there's the 3 over 2 sitting out front. Here's my x. If I add 1 to that, that gets me the 3 over 2 power. If I divide by 3 over 2, that's the same as multiplying by 2/3, like we just talked about. And then we have to add our plus c. Once we add our plus c, reduce, 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 and your answer will just be x to the 3 over 2 plus c. Okay, part C, the integral of 1 over x. Again, think to yourself, what did that come from as a derivative? And this is one that kids mess up a bunch. Let me show you something that people do wrong. They write this as x to the -1 power, and when they write it to the -1, what happens when you add 1? It becomes a 0. Can you divide by a 0? No. So that's how you know you're wrong, and you have to think, this is something on my neon sheet. So don't do that, and if you catch yourself dividing by a 0, then you know for sure you can't. And the answer to this question, looking at your neon sheet, is the natural log of the absolute value of x plus c, straight off the sheet. Okay? Next, if we move along, we have some basics. Okay, so this looks a little bit different than your notes, but very similar. The first thing here, number 5, for you guys, 5a, it just says again that the constant can be moved through the integration symbol. So I just did that in one of our examples, and that's the same as a derivative, so that's no big deal. Here, our next one, the integral of the sum of 2 different functions. You can go through and you can take the integral of each of the functions separately. Okay, so that's what they're showing you here. And then finally, the same thing with part C there. They're just saying that if you're subtracting, you can go through and break that up. Now, normally we don't even show that, so let me get into these examples down here, and you'll see how we typically handle that. Okay, so let's go to example 6. Here you see in example 6, we have a constant sitting out front. So what we just learned is that we can pull that 4 through the integration symbol, and then we just rewrite this like this, okay? And then we have to think to ourselves, what is the integral of the cosine of x? And so that's going to end up being the sine of x. So we have our 4 sitting out front. The integral of cosine is sine, and then we have to add our plus c. And it's as simple as that. Okay, it's nice because there's no product rule, there's no quotient rule, there's no chain rule. This is just, you know, if it's got to be on a sheet or you don't know the answer kind of thing. Okay, so the next one, this is what I was talking about. Could I go through and rewrite this as the integral of x plus the integral of x squared? Yes, I could, but why would I do that? Instead, I'm just going to go through and I'm going to take the integral of each piece as it goes. So the integral of x is x squared over 2. The integral of x squared is x to the third over 3, and then we put our plus c. And you can leave it just like that, okay? Okay, go to the next one. Try this one yourself, maybe. Same type problem. I'm going to shut my door even though it's 8 o'clock at night and now someone's vacuuming. Okay, so my answer would be 3x to the 7th over 7 minus, 2x to the 3rd over 3 plus 7x squared over 2 plus x plus c. Okay, so check and see if you agree with my answer. And if not, ask Miss Craig. Okay? And then we'll go to the next example. We have the integral of the cosine over sine squared. So I would say this is where things start to get a little bit harder, because I know how you all love trig. Okay, so looking at this, let's get creative. I just said to you a few minutes ago that there's no such thing as a quotient rule or any of our product rule, chain rule type things. So we have to get creative, and we have to get this to be one of the things on our neon sheet, or we can't do it. So looking at this, we have the cosine of x over sine squared. Let's try to rewrite this. Let's write this as the cosine of x over the sine of x times 1 over the sine of x, okay? And that whole thing is all together dx, right? So you can see I just basically split up the sine squared into 2 different pieces. If I were to multiply this back together, it's identical to what I have. Now, what's the cosine over sine? Did we say cotangent? Okay, hopefully. So we have the cotangent of x, and what's 1 over sine? Hopefully you're thinking cosecant of x dx. Okay, so by simply rewriting this and looking at it with just a creative spin to it, we get the cotangent cosecant. I like to think cosecant cotangent because in my head that's the derivative that I know, and I think what has the answer of cosecant cotangent, and when I get that answer, I'll know the answer to my question. Since you're new at this, go ahead and look that up on your neon sheet, and you should get negative cosecant of x plus c. Again, straight off of your sheet. Okay, and then we're going to go to our last example on this page. And again, we're going to have to figure out how to try to make this not look like a division problem, essentially, so that we can go through and apply our adding 1 to the exponent and dividing by it. So one time before I showed you how if you have, a binomial, trinomial, any polynomial over a constant, it's perfectly fine for you to split that up and write it as t squared over t to the 4th minus 2t to the 4th over t to the 4th. So all of that dt. This is a cool example. At least they finally switched the letter on us. This is just an independent variable. So since they're using t's, I have a dt. Before, we've been using x's, so I've been using dx. Okay, so let's reduce this thing before we get started. So that's going to get me t to the negative 2 minus 2, right? And that's still dt. And now that we have this, you should all be okay with taking the integral. So go ahead and take the integral for that last step. okay? So for this one, if I add 1, that gets me t to the negative 1, divide by negative 1, minus 2. Now, if there is no letter there, wouldn't it be t to the 0 power? So that means the integral would be t to the 1 divided by 1, and then you would add c. Okay, final answer that I would like, take this t to the negative 1, drop it to the denominator. I'll squeeze that in over here. So again, I want negative 1 over t minus 2t plus c. Okay, and there's your final answer. Okay, next page. Okay, go ahead and find the, actually this is a little more loaded. Do you see the notation here this time? Okay, the notation. We not only have the derivative outside, we have the integral on the inside. So what you should be thinking about is the fact that a derivative and an integral are kind of opposite operations. So what's going to happen when I apply them both? Do you have a guess in your mind? Okay, so let's see. So I always like to work from the inside out, so I'll just bring this d dx down, and I'm going to focus on the integral. Okay, the integral would be x add 1, divide by it. 3x add 1 and divide by it. Minus 5x plus c. Okay, that's the integral. Okay, and then from there, we would have to go through and take the derivative. Okay, hang on one sec.